Today is the 18th of March 2024. This will be our 8th video on trigonometry. Okay, we've been watching some interesting trigonometry and doing some very good examples, both for the foundation and higher paper. Okay, before I start the lesson, thank you everyone who have subscribed to our platform. Okay, I appreciate it a lot. And if you have not considered subscribing, can you consider subscribing, sharing, liking, and following us? Okay, please, if you subscribe, when you watch, share, like, okay, do whatever you want to help us circulate on the platform. Okay, I'll really appreciate that. And if the account is not yours, please don't misuse somebody else's account. Okay, if it's not yours, ask permission before you subscribe. Or when you are ask somebody to help you open your own account, it's very easy to do that. If I can do it, everybody can do it. Please follow my notes/script. You always see it in the comment section. Okay, this is maths. This is on interactive. So this is 0.1666667 because I've rounded it off. Okay, so if I'm explaining something around this side, it will be something concerning these figures. So please follow my notes/script. Beware of scammers. Okay, all of us. It's a warning I'm sounding to you, and it's a warning for me myself. Okay, if you text me and you say that you donated money to somebody, and if I've received it, please, I haven't, because I'm not asking for donation. Okay, I'm just trying to put out some tips and some knowledge for you to go out and get your Gcse maths. Okay, that is basically it. So for instance, I really want to know if you've used our platform diligently and how it has helped you. Okay, if whether you passed or not when results come this year. Thank you very much on that as well. Recap. Please watch last video for recap. Okay, at this stage I'm not doing a lot of recap, otherwise we will not move forward. Okay, recap, we'll just go back. The videos are linked, so just go back and watch last video. We've been looking at some interesting examples. Most of them are possible exam questions from the higher paper as well as from the foundation papers. Okay, some are calculator papers, some are non-calculator. Okay, so just go back and watch. Okay, at this time you have like a month Okay, so if you've heard the beginning of my announcement, there is no point listening to it over and over again on each video. Okay, you guys are no case. You can just forward it a bit and start exactly where uh the the video starts or the example starts. Okay, because at the end of the day, you subscribe if you are in that category. But if you haven't also subscribed, you can subscribe and then forward it, so you don't have to keep on listening to the beginning part over and over again. It's like a disclaimer. Okay, so you can do that to help yourself if it's because of time. Also, you can decide if this is your first video, then you can watch it, and then the other videos you just forward it a bit. Okay. uh we've been doing applying SOCA to a sine rule, Pythagoras theorem, to solve questions, and we've done look at some interesting angle of depression and elevation questions. Okay, today I want to bring some starters. We have been doing a lot of starter because we did terminating and recurring fractions, and I've been trying to bring you some fractions and to explain with the denominator where you choose whether it terminates or recur. Okay, if it's a calculator paper, I would advise you to use your calculator, because maybe there's a reason why they brought it in the calculator paper. But if it's a non-calculator and you are just supposed to take out the one that recurs or terminates, then you look at the denominator. For instance, the prime factors here are 2 and 3. So because of the 2, if it was only 2 and 5 or 2, then we'll say it terminates. But they say 3 here. Okay, so assuming there was we had to round it off. So if there was no rounding off, it would have been 0.166666666. So even though there is 2, because of the 3, it will recur. But assuming you want to put it to one decimal place, then it will be 0.2. If you want to put it to 2 decimal places, it will be 0.17. So you can terminate it, or you can allow it to recur. Okay, but trust me, in Gcse level, they are not going to give you fractions, okay, to confuse you. They will either give you a fraction with prime denominator 2, or fractions with prime denominator 3, 7, 11, where you can see clearly that it terminates. Okay, now 2 over 3, here it is 3, so it is only 3, so it's going to recur. But assuming you rounded it off, you're going to get 7 points. It's 0.7. Okay, but because of the denominator 3, the prime factor denominator 3, it will recur if you don't round it off. Okay, Now let's look at another one. Okay, 3 over 11. Here you can easily see that it will recur because of the prime factor 11. There is no 2, there is no 5. So you can stop at 0.27 and put 2 dots on the 1 dot on the 2, 1 dot on the 7. Okay, because even if you run it to 2 decimal places, it will be 0.27. To 1 decimal place, it will be 0.3. So you can terminate it to 1 decimal place by rounding it off. Okay, but because of the denominator of prime factor 11, it will recur. Okay, but as I said again, if it's a foundation paper, they will give you fractions that you can clearly see recur, or they will give you fractions that you can clearly see terminate. Okay, today we want to look at the application of sine rule. We've looked at SOHCAHTOA, how to use it to solve questions. We've looked at angle of depression. If you look at examples where we've used an example where we use the sine rule to solve a problem, found one side, and then use SOHCAHTOA to solve the main the tower question we had in last video. I also guess you go back and watch. So this is our sine rule. So basically what it says is the length A, okay, which is x, over sine 60, and then the length 10 here over sine 50, because it says find x. Assuming we know this angle and we knew this length, then we could involve that depending on what they want us to find. But because we are finding x, okay, so to apply sine rule, the angle opposite the length, okay, we need the length and the angle opposite. So x divided by sine 60 equals 10 divided by sine 50. So you need to set this right. Okay, if you don't set this right, everything you do from here will be wrong. Okay, as I said in the SOHCAHTOA, we were doing that. If you don't use the right function, whether it's tan or cos or sine, then you're going to get the answer wrong. You need to look. That's why the angle of depression and the elevation questions, you need to sketch, because most of the questions, they might not give you the sketch. Some of them, they might. Some of the exam papers give you the, if you look at it, some don't. So you have to sketch, and if they give you, you have to put in the right information and choose the right function. Immediately you are able to do that, you are assured you will get to the answer and you will get the full marks. So as I've shown you here, this is what we have. So to find x is 10 sine 50 times 60. Now, this will be a calculator paper because you don't have access now to the 4-figure table. So sine 60 will be 0.8660. Sine 50 will be 0.7660. So if you multiply 10 by 0.8660, you get 8.6660. Then you divide by 0.7660. So your length x here becomes 11.3054. To one decimal place will be 11.3. Now you need your units. This is in centimeters, so that will also be in centimeters. Okay, so 11.3 centimeters, one decimal place. So this is basically how you apply your sine rule. Okay, now the second example, again we are going to apply the sine rule. Okay, now look at it again. You have your triangle. Okay, now the rule says x over this angle is always the length opposite and the angle. So x over sine 89, okay, should be equal to 5.5 over sine 36. Okay, so x here now will be equal to 5.5 over 36 times sine 89. So sine 89 is 0.9998. Sine 36 is 0.5878. Okay, so x equals to 5.5 times 0.9998. Okay, when you do that correctly on the calculator, okay, you get 5.49992, okay, divided by 0.5878. And then if you do this correctly on the calculator, you get 9.35555. Okay, now this will become x equals 9.4 meters to one decimal place, because this is in meters, so I'll expect the x also to be meters. Do not forget your units. Another example, sine rule, application of sine rule. So here we have just one angle and we have two sides. Unlike the one we just did, the first two ones, we have one side and two angles. So we will still have to apply sine rule. Okay, so now we have sine 61 divided by 11, or 11 divided by sine 61, and then 12 divided by sine x. So we'll make sine x the subject. Okay, which at this stage we should all know how to make the subject. So what I just said is what I've written here using the sine rule. So sine 61 divided by 11 will be equal to sine x divided by 12. Okay. Don't do the length and then the angle, and then you do the angle and the length. Okay. If you are doing the length and the angle, then it should be the length and the angle. Okay. Or the angle and the length, then it should be the angle and the length. So here we make sine x the subject. So sine x will be sine 61 divided by 11, this one. If we move 12 to this side, times 12 here. So I'll just swap it around, okay? Sine 61 will be 0.8746. On the calculator, 12 times 8.746 will give me 10.4954 divided by 11. We did estimation. This figure here is approximately 0.9 times 12, so it should be less than 12, so that should be about right. So now x will be the sine inverse of 0.9541. So you go on your calculator, you press 0.9541, you press your second function or your shift, it becomes sine inverse, and then you press the sine button. Okay, so x will give you 72.58 degrees, but in degrees we would rather prefer to leave our answer to 1 decimal place. Okay, so it will be 72.6 degrees. So this angle here, okay, this angle x is 72.6 degrees to 1 decimal place. If they say to you, round it off to the nearest whole number, then it will be 73. The fourth one, applying sine rule again. Okay, so this is another example. Okay, so we have we don't know this angle, so we can use this v. Okay, but we need to find x. So x over sine 35, okay, will be equal to 8 over sine 51, or sine 51 divided by 8 should be equal to sine 35 divided by x. So using sine rule, okay, x over sine 35 equals 8 divided by sine 51. Now on the calculator, you can easily do this without writing all these figures, as long as you get your answer 5.9 meters, because the unit here is in meters. But assuming you are going to rush through and get it wrong, then you as well follow the steps. Okay, it will be an extra minute, but you rather not lose the 3 marks or 4 marks because you are just jumping stairs. Okay, steps. Okay, so now 8 sine 51 will be 0.7771. Sine 35 will be 0.5736. 8 times 0.5736 will give you 4.5888. Then you divide by 0.7771. Now on the calculator, if you do this right, you will get 5.91. One decimal place, 5.9. Okay, so your x here, this length is 5.9. Now your unit is in meters. Okay, so 5.9 meters. So today I've brought you some fractions again. Okay, that terminates and recur. We've discussed them, we've done a lot of this. So by now you should know that if I get a prime factors of only 2, 5, or 2 and 5, it will terminate. Okay, but if I get other prime factors, I'm going to get 0.166. Okay, so if there is a 2 and there is a 3, it will recur, but I can terminate it by rounding it off. Okay, if I get a denominator of prime factor of 7, it will recur, or 11, it will recur. Okay, then today basically I have gone on to show you how to use the sine rule to solve questions. Okay, that is what we've done. Okay, so previously we've been looking at using the right functions to look at angle of elevation and depression, and I've asked you to go and recap on that video. Okay, so tomorrow either I bring more examples to help you apply sine rule, or we just go ahead and look at how to apply the cosine rule, and then from there we'll do a couple of videos to look at some exam questions around trig, and then we'll leave it there for now. And then if you are doing some possible past questions and we meet some questions, we'll bring it up. And then some of them I might throw them in the starter to help us just recap. Okay, please, it doesn't mean I'm begging. It's a polite way of asking for stuff. Okay, try it. Okay, try using please and thank you in your language. It will help you a lot, and it will help you get some favors that you might not even deserve. So please subscribe, share after watching, like, follow. Okay, I will appreciate your help on that. Thank you very much. If the account is not yours, ask permission before you use somebody else's account, or ask somebody else to help you use your account. Beware of scammers. Okay, please. Thank you very much for watching my video today, and I'll see you in the next.